left on this, and then simply scroll to that element. So for that, we're going to use the scroll into view method here again. So let me show that to you. So document.querySelector, and now all I need to pass in is this ID, right? Because again, this exact string that we get from the href attribute is already the perfect selector, so we can just use that. Okay? And so this is a pretty common technique that we use for implementing a navigation like this. So we put the ID of the element that we want to scroll to here in the href attribute, so that then in the JavaScript we can read that. So we can read that href, and then we can select the element that we want to scroll to. So in this case, it's the element with the ID section 1, and that is exactly this one here. So exactly the first section. All right. So here we have the element now selected, and now all we need is to call scroll into view, and then with behavior set to smooth, just like we did already here before. Okay, and that's actually already it. So that worked beautifully, right? All right, and now the third one, and here we go. Well, that didn't really scroll to where I thought it should go. But now it did. Apparently, something weird happened there, but that's not a problem. Now, as you see, this actually works just fine, but the problem is that it's not really efficient. So we are adding here the exact same callback function. So this event handler here, we are adding it once to each of these 3 elements. So the exact same function is now attached to these 3 elements. And that's kind of unnecessary. I mean, of course, it would be fine for only 3 elements, but what if we had 1,000 or like 10,000 elements? If we would attach an event handler to 10,000 elements like this, so like we did here with the for each function, then we would effectively be creating 10,000 copies of this same function here. And so that would then certainly impact the performance. And it's really just not a clean solution in that case. And so the better solution, without a doubt, is to use event delegation. So in event delegation, we use the fact that events bubble up. And we do that by putting the event listener on a common parent of all the elements that we are interested in. And so in our example, it's this container that's around all of these links that we saw in the previous video. So remember, that is this element here. So we will put our event handler on this element here, and then when a user clicks one of the links, the event is generated and bubbles up just as we saw in the last video. And then we can basically catch that event in this common parent element and handle it there, because we also know where the event actually originated, right? So we can figure that out by looking at the event.target property. So that's what event delegation is. And so let's now go ahead and implement it. All right. So in event delegation, we basically need 2 steps. First, we add the event listener to a common parent element of all the elements that we're interested in. So let me actually write that here, because this is a really important technique. So as I said, add event listener to common parent element. And then in that event listener, determine what element originated the event, so that we can then work with that element where the event was actually created. So let's do that. Document.querySelector. And so remember, the common element of all these links is nav links. So again, it's this. Yeah, it's this element. And so this is where we add the event listener. And now we just need to figure out where the event actually happened. And remember that that is stored in event.target, right? So event.target becomes really, really useful now in this strategy, because we can now use this information exactly to basically see where that event happened. So as I click here, we can now see, well, that the event occurred from this element. And as we click here, then we see that it originated, of course, from this one. Okay? And as we click somewhere here in the middle, then we see that the click, of course, happened in this entire element, not in one of the links. And this part is actually important to notice, because now we actually only want to work with the clicks that happened on one of the links. So only this one or this one, but the click that happens here on this nav links element is not relevant at all. And so now we need a matching strategy here in order to match only the elements that we are actually interested in. All right. And in this case, the best way to do that is to simply check if the target has this navlink class. All right. So this is the matching strategy. And this can sometimes be one of the hardest things to come up when you use this technique. But many times I actually do it like this. So I check if the target element contains the class that we are interested in. So class list, and then remember we can use the contains method. And then we can simply check if it contains the class navlink. And so that's then this one here, right? And only if it does, then let's log link. So let's see. So as we click, we get link, you see? Or another one, and we also get link. But then as we click somewhere else, like here in the middle, then we do not get link. All right? And so now we successfully basically only selected the link elements itself. And so now we can basically do exactly what we did here before. So we actually also need to prevent the default. And so let's get all of this. And replace that here. Get rid of the comments. And this one here, so preventing the default, we actually always want that, or to do that. So no matter where we are clicking, nothing should happen. All right. So let's try that. Oh, and here we get this error, and we get null on line 87. So that's this. Oh, and of course, we still have a problem here, because the href attribute is now not on this, but it is on the element that was clicked. And so that is again e.target. So that's the whole reason why we're using e.target in the first place. So let's try now. And beautiful. Now it actually works. So you see, we still get the same sections here also logged to the console, and it scrolls to exactly where we want it to go. Awesome. So this works beautifully, and yeah, we successfully implemented event delegation, which is a lot better and a lot more efficient than simply attaching the same event handler to multiple elements. Instead, we simply added one big event handler function to the parent element of all the elements that we're interested in, and then we simply determined where the click event came from. And then we also needed this matching strategy, because we wanted to basically ignore clicks that did not happen right on one of these links. And coming up with this matching strategy, as I like to call it, is probably the hardest part of implementing event delegation. But don't worry, because there will be plenty of examples throughout the rest of the course. And so at some point, it will all make a lot of sense to you. So I hope that you're convinced that event delegation is a much better strategy, even though it requires a little bit more work than the first implementation that we did. And in fact, there is actually an even more important use case of event delegation, which is when we are working with elements that are not yet on the page on runtime, so by the time the page loads. And a great example are buttons that are added dynamically while using the application. So it's not possible to add event handlers onto elements that do not exist. But we will still be able to handle events on elements that don't exist at the beginning by using event delegation one more time. And we will actually do this later in this section. This lecture is going to be about traversing the DOM. So DOM traversing is basically walking through the DOM, which means that we can select an element based on another element. And this is very important because sometimes we need to select elements relative to a certain other element. For example, a direct child or a direct parent element. Or sometimes we don't even know the structure of the DOM at runtime. And in all these cases, we need DOM traversing. And this video is going to be another very nice reference lecture for you. And so let's now work with this h1 element here. And from here, we're going to go downwards, upwards, and also sideways. So let's quickly inspect this element. All right. So we see, so here we have the h1 element, and in there we have some text, we have some comments, then we have this span element, then some more text, and even more elements. And so this is going to be a lot of fun exploring a couple of different methods and properties to walk around this element. So let's start by selecting it. Maybe we already did that before somewhere, but that doesn't really matter. So let's start with going downwards. So basically selecting child elements. So the first way of doing that is to use query selector, because we already know that query selector also works on elements, not only on the document. So let's simply log to the console h1.querySelector, and then let's again see here what we could select. So we have this class highlight and this class highlight. So that's these two green ones. And so let's select them here. So that's actually query selector all, because there are two of them. And so class highlight. So let's take a look. And indeed, here they are. So this here indeed selects all the elements with the highlight class that are children of the h1 element. And that would work no matter how deep these child elements would be inside of the h1 element. Okay, and that's very important to notice. All right. Now in this case, these two elements here are direct children of the h1, but as I said, it would go down as deep as necessary into the DOM tree. Okay? And also, if there were other highlight elements on the page, so elements with this class, they would not get selected, because they would not be children of the h1 element. All right? So these are 2 points that are important to note here about query selector and query selector all. Now, sometimes all we need are actually direct children. And so for that, we can use h1.childNodes. So let's take a look. And so here we actually get all kinds of stuff. So we get text, we get a comment, and we get then these elements. And that's because we already know that nodes can be anything. So they can be text or elements or even comments as we have here. Okay, so this really gives us every single node of every single type that there exists. But many times we are simply interested in the elements themselves, right? So if we wanted the text, we could use .textContent or .innerHTML. So child nodes is not that used, but instead we can use children, just like this. And this then gives us an HTML collection, which remembers is a live collection, so it's updated. And so here we indeed only get the 3 elements that are actually inside of the H1. So that's this span, this breaking, and this span again. All right, but this one works only for direct children, so keep that in mind. Okay, finally, there's also first and last element child. So these names are a little bit confusing, but one more time, that's because of the messy nature of JavaScript with all of these things being implemented at different points in time. And so therefore it was difficult to keep consistent naming conventions. But anyway, let's use first element child. And so here it already is, style.color, just so that I can show you that we can actually also set these properties or use them to set something like the style. So for example, we can do this, and then only the first child here gets now this color set to white. So basically that's this element here, which is the first element here of all the children. That's why it's called first element child. And we can of course do also last element child, and let's say this one to black. So it's a little bit different now. It used to be, let's say, orange red. I really like this one. And so now it looks a little bit more crazy. Okay, but now let's go upwards. So going upwards, so basically selecting parents. And for direct parents, it's actually very straightforward. So here we have h1.parent node. And so that one is similar to child nodes. So let's see. And so it's this header title. So as we open this up, we see that indeed this h1 here is inside of header title. And so this is the direct parent. And so that's why we get this. Then there's also the parent element, which is usually the one that we are interested in. But in this case, it's simply the same. All right, because this element is also a node in this case. All right. However, most of the time, we actually need a parent element, which is not a direct parent. Or in other words, we might need to find a parent element no matter how far away it is in the DOM tree. And for that, we have the closest method. So that's h1.closest. So let's say that on the page we had multiple headers, so multiple elements with the class of header. But for some reason, we only wanted to find the one that is a parent element of h1, so of our h1 element here. And so for that, we can use closest. And so the closest method receives a query string just like query selector and query selector all. All right. So dot header, and then let's do something with it. For example, change the background image, or just change the background. And I will set it here now actually to a CSS variable. So let me show that to you. So here we have all of these CSS variables, or as they are officially called, custom properties. And we use them in CSS by doing this. So by writing variable and then a color. And so, well, let's actually use a gradient. So gradient, yeah, so this one. Okay, just so you can see that we can use custom properties also in CSS. So give it a save, and beautiful. Well, it's not that beautiful, I must say, but indeed, it worked. So it selected the closest header to our h1 element, so the closest parent element that has this class, and then it simply applied our style to that element. So this is a very important one, and we're going to use it all the time, especially for event delegation. So take a note of that, or just keep it in mind. Now, if this selector here actually matches the element on which we're calling closest, then that's actually the element that's going to be returned. So let me also show that. So we are calling this on the h1 element. And so if we're looking for the closest h1, then that's going to be exactly the element itself. And so, as I just said, then that's going to be the one that will be returned. Let's make this a bit more prominent here. And so you see that indeed, now this is the h1 element itself. So we can think of closest here as basically being the opposite of query selector. So both receive a query string as an input, but query selector finds children no matter how deep in the DOM tree, while the closest method finds parents, and also no matter how far up in the DOM tree. All right. So very important method here to keep in mind. And now let's go sideways. So selecting siblings. And for some reason in JavaScript, we can only access direct siblings. So basically only the previous and the next one. So that's h1.previous element sibling, like this. And then there's also the next element sibling. All right. So the previous element sibling is null. And so if we take a look at that, it makes sense because there is nothing there. So this is the first child of this parent element, and therefore it doesn't have a previous sibling, but it has a next sibling. And so that's this h4 element, which comes after it. And just like before, we also have the same methods, or actually the same properties for nodes. So that's just previous sibling and next sibling. So let's see. And here the previous sibling is now actually text. So not sure what that is. Well, it's not really important because again, most of the time we're going to be working with the elements anyway. Now, if we really need all the siblings and not just the previous and the next one, then we can use the trick of moving up to the parent element and then read all the children from there. So let's see. So h1 dot parent element. So that's just like we learned before. So the direct parent, and then from there we can get all the children. So just like we learned here also before. So dot children. And so now we get all of the siblings. And that of course is going to include itself. So that's all of these elements, and all of them are siblings. And just for fun, let's actually do something with them here. So this is an HTML collection, remember, so it's one more time not an array, but it is still an iterable that we can spread into an array. So we can do this, and it will then create an array from this. And then we can loop over that array and do something using the for each method. So let's say that we wanted to change some style to all the siblings, but except the element itself. And actually that's more straightforward than you might imagine. So we can simply do this here. So we can check if the element is different or equal also works than the h1. Because h1 is our original element itself. And so comparisons between elements actually work just fine. Okay? And so when the element is not the h1 itself, then let's change the style. And let's say we want the trans form property just to scale them a little bit. Let's say 0.5. So scaling them by 50%. And indeed, all the other three siblings are now like 50% smaller. All right. And so this is how we can work with all the sibling elements of one element. Great. And that's actually the fundamentals of DOM traversing. And we're going to need them all the time, and especially when we're doing some more complex event delegation like we will do throughout the rest of this section. In this video, we're going to implement a very popular component, which is a tabbed component. And you will see tabbed components on many websites these days, so it's great to learn how to build one yourself. So the component that we're going to build in this video is this one. Now, a tabbed component can appear in many different ways, but what they all have in common is that they have some kind of tabs, like these here, and when you click the tab, then the content of this area below will change. And so that's exactly what happens here with these buttons. So basically these three are our tabs, and then as we click on one of the tabs, it will reveal the associated content. So a little bit like tabs here in our browser, right? So each browser tab has its own web page, and so here each tab has its own content area, basically. So I'm sure you've seen this on other websites, and so let's now go ahead and implement this ourselves. Okay. Now, for this component, we actually need a bunch of HTML. So let's first take a look at that. So the whole tabbed component in our case is called operations. So let's scroll down here also. And so this section here is about the operations we can do on a bank account, and therefore this component here is called operations. And you can also see that here on the page. Then we have the tab container, basically. So that's this element. And so you can also see it here again, and it's the element which will contain the three tabs. And so each tab is itself a button, and it has this class of operations tab. Okay. Then below that we have the content. And in fact, we have three contents. So we have one content element here for each of the tabs. All right. So the first one here, as you see, is called operations content 1. Then the other one is operations content 2 and operations content 3. So as we click on one of these tabs, we will not create any new content. What we will do instead is to hide the other tabs, basically. So you see that right now, this first one here has the operations content active class. And so therefore this one is visible and all the others are hidden. And what's also important here is that these buttons here, they have this data tab attribute. And so this one is number 1, and this will then be associated with this class name here. So operations content and then again 1. But more about that in a minute when we actually implement this ourselves. So for now, we just need to get down the basic structure of the HTML here. And it might be a good idea for you to pause the video and take a minute or two to get yourself familiar with this HTML structure and all of the class names that are involved here. Okay, and you can even take a look at the CSS, because there's also a lot of CSS involved here. All right, so of course I couldn't write all of this code here together with you now, because that would take way too long. All right, but anyway, let's now build this tabbed component here. And we're going to start by selecting the tabs. Okay, and I will keep the elements here open so we can see it at all time. And so you see that the buttons, they have the class operations tab. So tabs equal document.querySelector all, and then with the class operations tab. Then let's also select the tabs container and so that is this element here. Let's actually go ahead and copy it. And finally, also the 3 content areas. So that's here, operations content. You see, cannot copy it for some reason. Doesn't matter. So tabs content is document.query selector all. So because again, we have 3 of them. All right. So we have our selections nicely done. And now we can actually work on the functionality. And let's start by adding event handlers to these buttons here, right? Because that is the action that we actually want to handle in this component. So we could do it like this. So taking all the tabs, and then on each of them, we could attach an event handler. So for example, like this. So for each, because we want to do it on each of them, so we get then each tab, and then tab.add event listener, click, and let's just use a quick arrow function here, because this is really just a demonstration. Well, nothing happens. Let's try to reload this page. Yeah, indeed. Now we get the tab locked to the console. Now, however, as we already learned in the last video, doing this here is a bad practice. Because what if we had like 200 tabs? Then we would have 200 copies of this exact callback function here, and that would simply slow down the page. So that's not at all desirable. And so let's get rid of this and one more time use event delegation. And remember that for event delegation, we need to attach the event handler on the common parent element of all the elements that we're interested in. And in our case, that is this tabs container, right? So we have our buttons here. So right here, our buttons, and the common parent of all of them is this tab container that we already selected previously. And so let's attach our event handler to that element instead. So tabs container.add event listener, click. We need the event, of course, so that we can figure out where the click happened. And so let's now actually work on our matching strategy. Okay, so we already know that we are interested in the buttons. And so let's now figure out which button was clicked. So let's actually create an element called clicked that we can then use to work with. And so what about this? So what about simply using the e.target? Well, let's see. So in our console, let's now click somewhere here. And indeed, now we got the button that was clicked. Okay. However, there is a problem when we click here on this number. So you see that now we did not get a button, but we got this span element. And that's because inside of this button, we actually have another element. And so now, even though it looked like we clicked on the button here, or here, for example, actually we are clicking on this span element, right? So we are not actually clicking on the button, but we still need the button. So no matter if we click on this button itself or here on the span element, we actually need the button element itself, because from that button, we will need to read this data tab attribute here. Because as I mentioned earlier, this one contains the number of the tab that should become visible. And so here, this data attribute becomes really important to store information in the DOM. So basically, we need a way of finding the button element whenever we click on this span element, right? Now, one simple way to fix it, which would not really fix it actually, is to do some DOM traversing and simply select the parent element. We can move up the DOM tree, and instead of simply taking e.target, we can use the parent element of that. So let's see what happens then. And so now indeed, when we click on the number, we get the button. And so again, that's because that is the parent element of that span. Now the problem appears when we click on the button itself, because now of course we will also get the parent of the button element. And so that is this container. But of course that is not what we want. So basically what we want is to get the button no matter if we click here on the span or on the button itself. So we need a way of selecting the parent element that is always a tab. And can you think of a special method that we learned previously to do that? Well, the solution is right here in the previous video. Well, and that's down here somewhere. So remember that we want a way of going upwards, but we want to specify that we want to select an operations tab. And so we can use this closest method for exactly that. So remember that I said that this method is going to be really helpful in event delegation. And so now that's actually the case. Okay, so this method makes it really easy for us to dynamically get the element that we're interested in. So here, instead of always selecting the parent element, we will search basically for the closest operations tab. And so here we need the exact same query as that. All right, and this should actually now fix our problem. So let's see. When we click the button itself, then we get the button. And when we click the number here, so the span, then we also get the button, because now it finds the closest parent with this class name, which indeed is the button itself, so the tab. And here we get the tab number 2, as you can see down here. And here we get tab number 3. Great. And let's actually immediately do something with this selected tab. So the tab that is currently active here has a different style, as you can see. So it's a bit moved up. And so that's because the active tab basically has this class. So where's that? It has this class of operations tab active. All right. So we can simply add that to the element that was just clicked. So class list dot add operations tab active. Okay. And now as we click, you see that it activates basically this tab. Now, of course, later, then all the other tabs will have to move down, but we're going to take care of that in a second. Because now watch what happens when we actually click on the tabs container itself. So outside of any of the buttons, but still in the tabs container where this event listener is actually attached to. So you see that we get null here. And that's because null is the result of the closest method here when there is no matching parent element to be found. So of course, when we click here in this tabs container, then there's going to be no parent with this class. And so therefore, as I just said, we get null. And so we need to fix that now in our code and basically ignore any clicks that happen on that area. So basically ignore any clicks where the result is then null. All right. So we can do that by saying if there is no clicked, then return immediately. And this is something that we haven't done before. So what I'm doing here is called a guard clause. So it's basically an if statement which will return early if some condition is matched. So in this case, when there's nothing clicked, then we want to immediately finish this function. And in this case, when we have null, which is a falsy value, then not falsy will become true, and then the function will return, and none of the code that's after it will be executed. But of course, if clicked does exist, then this return will not be executed, and the rest of the code will be executed just fine. So this is a more modern way of writing this. So we could have written instead also, if there is a clicked element, then do this. And this is the more traditional way, as we have been doing it all the time. But this is actually more modern because it looks a bit nicer, because we don't need to create all these additional blocks. So in this case, just this block. But sometimes when we have so many conditions, it can become a little bit confusing. And then it's a bit cleaner to simply return the function immediately if a certain condition is matched. And again, in this case, whenever there is no clicked element here, then we want to simply return the function right away. And so then that code here will not be executed. But otherwise, of course, it will be executed. And so let's now see what happens. So now clicking outside, nothing happens. Of course, we still get the null here, but no error occurs because now JavaScript is no longer trying to execute this line of code here. Okay. But now let's actually take care of basically putting all of these other buttons down, as I was saying. So when I click one of them, then the other ones should move down. So basically, we should remove this class from them, right? And so the solution to that is before we add this class here to anyone, we will simply remove it on all of the tabs. So we remove them on all. So that's all the tabs dot for each. And so each tab I'm simply calling T here, and then tab dot class list dot remove. And so now that should work. And yeah, it does. Okay, so this is something that we do quite usually. So basically clearing the class on all of them and then only add it afterwards on one of them. So let's add a comment here, active tab. But now finally, let's actually activate the content area itself, because that's the main part that we're actually interested in. Now, remember that the information about which content area should be displayed is here in this data attribute. So let me click again. And so in this case, we want the tab number 2. And so that's this number 2 is encoded here basically in this data attribute. So having the number 2 here means that we want to select the element which has the class of operations content 2. Okay, so let's do that. Let me grab this here. So this selector, and then let's select it. So document.querySelector. And now I'm using a template string here because, of course, we don't want to hardcode the number 2 here, but instead we want to get that exactly from the data attribute that I just showed you. So let me just show that again to you. Now we get an error here. Let's just put something there for now. So it is called data tab. Okay. And so remember, all these attributes are in the element and then in the dataset property. So the element that was clicked is indeed stored in our variable clicked, right? So every time we click a button, that button is then stored in the clicked variable. And so then .dataset .tab. So that's only the part after the data, remember? So it's just tab. So in this case, it's going to be 2. And so we already have that now selected, and then we want to add a special class to it. So that's class list.add And let's just check out the class that we need to add. So we can see that here on the first content area, which is already active. And so the class here is operations content active. Okay, and one more time, you can check out the CSS to figure out why actually this makes the element active. And we can quickly do that ourselves. So here it is, actually, the active, right? And so basically what this does is to change the display property to something which is not none. So previously, without this active part, so just operation content makes it display none, which basically hides it. But then as it becomes active, we give it display grid and then specify all of these properties there. All right. So this should actually already be working. Just to really see this a bit better in the console also, let's log this value also to the console. Okay, but let's see. And indeed, it now appeared down here. Great. So it's no longer hidden. And indeed, we successfully read that value here from the data tab, which is 2. And the same is going to happen here for 3. And so you see that the content number 3 also appeared down here. Now, of course, this is not quite finished yet because we want the other ones to be hidden. So that's the whole idea of this component. And so basically all we need to do is to do the same that we did for the tabs. So basically removing the active class for all of them before then adding it to the one that we're interested in. All right, so basically just what we have here. So let's select all the contents, and that we actually already have here, right? So tabs content is also a node list because of query selector all that we can now loop over and then remove that active class from all of them. So tabs content dot for each, and I'm just calling it C very short here. So C for content. So class list remove. And so you see that it's always the same idea. So it's all about removing and adding classes to manipulate the page to look just like we want. All right. So this comment is actually more here. So activate tab. And here, remove the active classes for both the tab and the content areas. And with this, actually our component should already be working. So let's see. And yeah, beautiful. It works great. All right, let's just get rid of all these different console.logs here because we only need them for development. But now we're done. So let's just quickly recap. And as I just mentioned a minute ago, the whole idea when we build components like this is to just add and remove classes as necessary to manipulate the content to our needs. And actually the exact same thing we did with the modal window. So if you take a look at the code, it's a bit similar. So to hide and display the modal window, all we do is to add and remove this hidden class. Now in this case, it's a little bit more complex, but the idea is always the same. It's to work with classes that have some styles for showing and hiding the classes. And so if you're not yet really familiar with CSS, it's also important that you really check out the CSS to build these components for yourself. And the same goes for the HTML. But of course, I could not write this code here as well, because then this tutorial would take like 1 hour instead of 15 minutes. But anyway, I hope that this was fun. Make sure to understand what we did here, including the HTML and CSS. And then let's go right to the next video. Let's now create a nice effect on our page navigation where all the links fade out when we hover over one of them except for the link that we actually hovered over. And this will teach us something really valuable, which is how to pass arguments into event handler functions. And the effect that I mean is this one. So when we hover over one of the links, you see all the others fade out like this, and that includes even the logo there on the left side. So let's do that here in our page, and let's again start by taking a look here at the HTML. So we have these links. So each of them is a nav link. And so these are the elements that we're going to be working with. So menu fade animation. But now, of course, we do not want to attach an event listener to each of these links. So we already know that we should do event delegation here instead. So let's find the common parent element of all of the links, and also including the logo there. So if we were only working with the links, it would be this element, but we also want to work with the logo here. And so let's actually use this entire navigation here as our parent container on which we will handle the event that is going to bubble up from the links. So keep in mind that all of this works because events bubble up from their target. So let's select the navigation here and store it in a variable .querySelector.nav. Okay, and actually let me put this here at the very top because we are going to need this a bit later. And it is a good practice to have all of these at the top. And the same actually here. So why not have all of the selections right at the top? That makes it a bit easier to understand the whole file. Okay. But anyway, let's now attach an event listener to that navigation. But now we're not going to use the click event, but instead the mouse over event. Okay. And I think that previously we have already used the mouse enter event, and mouse over is actually similar to mouse enter, with the big difference that mouse enter does not bubble. Okay. But here we need the event to actually bubble so that it can even reach the navigation element. And so therefore we use mouse over. All right. So then attach the function here. And there are also kind of opposite events of mouse over and mouse enter. And we use these to basically undo what we do on the hover. So the opposite of mouse enter is mouse leave, and the opposite of this mouse over is mouse out. And so we're also going to need that one. So let's put that here right away. So mouse out. All right. And as always, if you need to know more, then you can check out the MDN documentation. Great. So we have our parent element. And now, as always, we need to match the element that we are actually looking for. And so in this case, that are these elements with the navlink class on them. And so let's simply check for that. So if e.target, as you already know, .ClassList.contains the navlink class, well, then let's do something. So you see that this time around, I'm not using the closest methods. And that's because there are simply no child elements that we could accidentally click here in this link, right? So that was the reason why we needed the closest method here in this tabs, because we had this button, but then we could also click on the span element. And so here we then needed to find the closest element, so the closest button to both of these places. Okay, but here that's not necessary. And so therefore a simple check like we have here is enough. And so now we can actually say that the clicked is then e.target. Okay, so I called it clicked before. Let's call it now actually the link. But this is similar to what we did before also. So creating a variable which contains the element that we're working with. All right, and so now next up, we need to select the sibling elements. So basically all the other links. All right, and remember that we can do that by going to the parent and then selecting the children from there. Now, in this case, actually the parent of nav_link is this nav item. And the only thing that nav item includes is always just one link. So you see that each of the link is actually inside of one nav item like this. And so now we would have to move up manually, not just once, but twice. And so instead of doing that, we will again use the closest method. Okay. So again, instead of moving up manually like 1 or 2 steps, we can simply search for a parent which matches a certain query. And so that's a bit more robust, because even if we would then at some point maybe change the structure of this HTML here, then our JavaScript would keep working. All right, so let's say or link, and then find the closest parent, and let's actually search for nav again. Okay, even though that's not the closest parent, I mean, there is another parent to these links, which is this one here, but it's no problem of also choosing an even higher up parent like we are doing here. So we are now at a parent of all of the links, and so now from there we can search for the nav links again. And so these are then going to be the siblings of our initial links. And so, as we already learned before, we can use query selector on an element to search for a certain query only in that element. Okay, and we are looking for these nav links, of course. And now let's actually also select the logo, and we could select it manually also by its class name, but let's just suppose that there are many navigations on this page. And so again, to make the solution really robust, it's best to simply move up to the closest parent, in this case the navigation, and then from there we simply search for an image. All right, and so this then will work not only on this navigation, but it would work also on others. So this selector here is simply for any image which has the image tag. Okay, all right, so we have all our elements selected. Now we just need to change the opacity basically of the siblings of the selected link. So siblings dot for each, and now we actually need to do that comparison that we did before. So checking if the current element is not the link itself, because of course this sibling here, so these siblings, they will contain our initial link as well. Okay, so it needs to be different from link, and actually here we need a query selector all, right? We want all the links, not just the first occurrence. Okay, but then for all the others that are not the original link, we want to change the opacity to 0.5. And indeed, we want to do the same with the logo. So logo.style. And let's see what we have already. And you see that it works, right? Beautiful. Now, the thing is that, of course, it doesn't go back. So once we have it at 0.5, it will not automatically go back to the opacity of 1, which is the original one. You see? So when I hover this, all the others become 0.5, but as I move out, then everything remains the same. Okay? And so that's why we have this mouse out event to basically undo what we did here. So let's take all of this, paste it here, and change this to 1. All right. And so let's see what happens now. And yeah, everything goes back to 1. And so this actually works. Now, of course, it doesn't work with the logo, because this entire effect only works if the target contains the nav link. class, right? But that wasn't the point anyway. We just wanted this to work on any of the links. And notice that this button here is actually also a link element, and so it also works on that one. All right. So our effect here is actually working already, but this is of course very repetitive. So the code here is always the same, and so we need to make our code a little bit more dry here, of course. So let's refactor this code. And usually refactoring works by creating a new function. And so let's do that here. A function, and we will need some arguments here, but more about that later. So what we need to do now is to compare these two pieces of code that we are trying to refactor, and then figure out what is the same and what is different. So in this case, that's pretty simple. So all that changes is that here we have the opacity 0.5, and here we have the opacity of 1. And so we can simply take this code and create an argument or a parameter for that opacity. And we can then pass that opacity into the function. All right. So of course we also need the event here. So that's going to be the first one. And then we need the opacity. And so here we simply replace that by opacity. Okay. And so like this, we refactored our code very nicely here. But now, how do we actually use this function here? So usually when we have the event handler as a separate function, all we do here is to pass in that function, and then it's going to work just like this, right? So we have done this many times throughout this course, right? But now the problem is that we actually want to pass in values into this function, right? So we need to tell this function to use the opacity of 0.5 in this case and of 1 in this case. All right. Also, we need a way of passing this event. So right now, none of this would work. So let me show that to you. So not clicking, of course, but you see it would not really work. Okay. So maybe you would think that we could do this. So like maybe passing an event here and then 0.5, which is the opacity that we want. But this, of course, is not going to work. So the first problem is that E is, of course, not defined. But the main problem really here is that addEventListener here expects a function. So we need to pass a function. But if we call the function, then all of this here will become some other value. In this case, that's undefined because we don't return anything from this function. All right. And so this is simply not going to work. So we talked about this many times, but it's always good to remember that JavaScript indeed expects here a function and not just some other regular value, which would be the result of calling the function like this. Now the solution to this problem would be to still have a callback function here, like a regular one, which JavaScript will then call for us whenever the event happens. And then in here, we could then actually call this function with the event, which is this one, and then our opacity, so 0.5. And so this works because here we are basically calling the function manually. So this will only be executed as soon as JavaScript executes this function value. And so here we are back to working because here we are back to passing in a real function. Okay? And then let's right away do the same here. Set it to 1. And now it should be working again. And it does indeed. Okay, so that is the second version of our code working, but we can actually do even better and remove these anonymous callbacks functions here altogether. So this looks a little bit ugly, right? Like having just this one function, which in turn will call another function. And so, as I just said, we can do even better, and that is by using the bind method that we already studied before. So remember that the bind method creates a copy of the function that it's called on, and it will set the this keyword in this function call to whatever value that we pass into bind. Okay, so let me just do that here in practice. So handle hover and then dot bind. Okay, and I think we actually already did an example like this. So using bind in an event handler. And so let's set 0.5 here just as before. All right, and now let's do the same here. So handle hover dot bind and then 1. And so this is going to work because this is going to be also a function, because bind, remember, returns a new function. Now in this function, the this variable will now be set to this value, so to 1 here and to 0.5. And so let's check that out. So the this variable, okay. And so now you see indeed that it is either 1 or 0.5. All right. Now remember that usually the this keyword is equal to current target. So let's also check that. Okay, but current target will of course remain unaltered. So you see that it is still of course the navigation element. Okay, so by default the this keyword is the same as the current target, so the element on which the event listener is attached to. But when we then set the this keyword manually, of course it becomes whatever we set it to. And so now, just like before, we can use that this keyword and use that here. All right, because the this keyword is now our opacity. And so essentially we use the bind method here to pass an argument into a handler function. So let me just write that here. Passing an argument into handler. And I'm using quotes here because, of course, this is not really an argument. So in fact, we don't even need this here. And in fact, it is impossible to pass another argument into an event handler function. So any handler function like this one can only ever have one real argument. And so in this case, can only ever have one real parameter, and that is the event. But if we want to pass additional values into the handler function, then we need to use the this keyword like we just did here. And if we wanted multiple values, then we could, of course, pass in here like an array or an object instead of just one value. So this is kind of a workaround into the fact that the handler function can only take one argument. So it's a really nice effect, and as I said in the beginning, it also taught us how we can pass arguments essentially into handler functions. Let's implement another pretty common feature on web pages, which is that the navigation bar becomes attached to the top of the page after we scroll to a certain point. And this is called a sticky navigation, and so let's build one for our site. So the effect that I'm talking about is this one. So as we scroll down, once we then reach a certain point, the menu bar here becomes attached to the top of the page. And once again, I'm sure that you have seen this in many pages that you visit. Now let's just check out the HTML here, just to see how this works. So we make this navigation sticky basically by adding this sticky class whenever we reach a certain position. And so this sticky class, as you can see here on the right side, all it does is to set the position to fixed, and it also changes the background color to this transparent. So you see that we can actually see through this navigation a little bit, which gives it a really cool effect. Okay. So sticky navigation. And to implement this, we're going to use the scroll event for now. So there's actually a better way of what we're going to do in this video, but let's start by working with the scroll event now, because sometimes that's good to know as well. So the scroll event is available on window. All right, so not document, but really window dot add event listener and then scroll. Okay, so this event will be fired off each time that we scroll on our page. Okay, and let's start by taking a look actually at the event, just so you see that it actually fires each time that I'm scrolling. So I just scrolled this little bit and it already created all of these events. So it fired all these times. So the scroll event is not really efficient and usually it should be avoided. But again, for now, let's use that. And now let's start by getting our current scroll position. So let's use window.scroll y, just as we learned before. And so this scroll position here is really on the window object and not at the event. So in the scroll event, this event object here is actually pretty useless. We don't even need it here. Okay, so let's just reload here. And so as we scroll, you see that each time the event is fired, we get the current scroll position. And remember that this is the position basically from the point in the viewport, so this point here, to the very top of the page. And that's why in the beginning we start at 0, because now the visible part of the site is exactly also at the top of the page. Okay, so remember, to make the navigation sticky, we will add that sticky class that I showed you earlier. But now the question is, when exactly should the navigation actually become sticky? Well, it should happen here as soon as we reach the first section. So basically as soon as we reach this position. So this line here marks the beginning of the first section. And so when we reach this position, we want to make the navigation sticky. Now, of course, we're not gonna like hard code the value here. So I could take like 565, but that doesn't work because the size of this element that comes before is actually dependent on the viewport size. So if I do this, then you see that the first section starts way earlier. So like at 300. And so we cannot hard code the value, and therefore we need to calculate it dynamically. So how do we do that? Well, remember that we can determine the position actually of this first section. So let's do that. And I think I already have it selected up here. Yeah, so section 1, which is this one. So we need to do this outside actually of this event handler. So that section 1 dot get bounding client rect, remember. And so let's call this initial coordinates, so just coords, and take a look at it. And so now we get this current top value here. Where is it? Right here. So we get the current top value of this section. And so we can now work with that. And it's even better if we do this when scrolled to the top, because then basically this top position here is all the way from the top of the page all the way here. So all the way to the beginning of that first section. Okay, and so let's now use this value to add our sticky class. So we can say that whenever the window.scroll position in y is greater than the initial coordinates at the top, then we want to add this sticky class, right? And if not, then we want to remove it. So I can use nav here because I already selected it in the previous lecture. So nav is of course this entire navigation bar that we also worked with in the previous lecture. So remove here. And here indeed we need a new line. And so now that works. And so let's check this here. And wait for it. And indeed, now it's here. So now the sticky class was added because we reached the position in the page which is greater than the distance of this first section from the top. All right. So this works just fine now, but as I mentioned before, this is pretty bad for performance. So using the scroll event for performing a certain action at a certain position of the page is really not the way to go. And again, that's because the scroll event here fires all the time, no matter how small the change is here in the scroll. And so that makes for a pretty bad performance, and especially on mobile. Like on a modern computer, of course, you're not going to notice anything. But if you're using this page maybe on an older smartphone, then it's not going to be so nice. All right. And so in the next video, we're going to look at a better and way more efficient tool, which is the Intersection Observer API. All right. So let's now implement the same sticky navigation that we implemented in the last video, but this time using the new Intersection Observer API. But what actually is the Intersection Observer API, and why is it so helpful? Well, this API allows our code to basically observe changes to the way that a certain target element intersects another element, or the way it intersects the viewport. And so from this definition alone, I think you can see that this will actually be useful in implementing our sticky navigation. But let's actually start this video by learning how the Intersection Observer API actually works, but without our sticky navigation, because at the beginning, this can seem a bit intimidating and confusing. Okay, so to use the Intersection Observer API, we need to start by creating a new Intersection Observer. So that's Intersection Observer, just like this. And then here we will have to pass in a callback function and an object of options. But let's leave that for a bit later. Okay. So let's first store the result of calling this function into a new variable. So let's simply call it the observer. And so now we have to use this observer to basically observe a certain target. So observer, and then the method we call on that is observe. And then here the target element. And this one will be section 1. And so this is an element that we already selected before. So this will make a bit more sense once we actually create the callback and the options here. And let's start by the options. So const, let's call it the observer options. So ops options. So this is going to be an object, and we can also already create the callback function. Let's simply call this observer callback. All right. And of course, we could have created these right here, because this is where we will now pass them in. So first the callback, and second the options. Okay. And so once again, we could have written the function and the object directly in here, but I think it's a bit cleaner to have them separately. So let's now start with the options here. And so this object needs first a root property. And this root is the element that the target is intersecting. So again, this here is the target, and the root element will be the element that we want our target element to intersect. And again, this will all make more sense once you see this in action. So we could now here select an element, or as an alternative, we can write null, And then we will be able to observe our target element intersecting the entire viewport. All right. So basically this entire rectangle here, which shows the current portion of the page. Okay. And then second, we can define a threshold. Threshold. And this is basically the percentage of intersection at which the observer callback will be called. So this callback here. So again, that's very confusing. Let's just set it to 10%, which is 0.1. And then when we have this callback function here also created, then we will see what actually happens here in practice. All right. So this callback function here will get called each time that the observed element, so our target element here, is intersecting the root element at the threshold that we defined. Okay, so take note of this because this is actually a bit hard to figure out from reading the documentation. And so it's a good idea to keep notes of what I'm saying here. So in the current example, whenever the first section, so our target here, is intersecting the viewport at 10%, so the viewport because that's the root, and 10% because that's the threshold. So whenever that happens, then this function here will get called, and that's no matter if we are scrolling up or down. All right. And this function will get called with two arguments. And so we can specify them here. And that's the entries and the observer object itself. All right. So this object here basically will also get passed into the callback function. All right. Now in this case, we're only interested in the entries, but sometimes using the observer is also useful. Now we can have actually multiple thresholds. So here we can have an array, and I will do that in a minute. And so these entries here are actually an array of the threshold entries. Okay, and so in this case, again, there's only one element there, but let's create a more general function already, which basically loops over these entries, so that we can take a look at all of them. And so let's just do that. So basically simply log them to the console, and that will already be good enough for us to take a look at how this all works. So entry, and so you see I'm using an arrow function here, but of course any other function would work just the same. Let's give it a save now. And you see that already we get an intersection observer entry. And so that is this entry here. And so this is not really interesting yet because this is just the first one that we got. And we see that the ratio here is at 0. But let's see in a second what that actually means. So I will start scrolling here. And you see that now we actually got our first real entry here, which appeared here because our target element came into the viewport. So our target element is this whole H1 that's down here. And so you see that it started intersecting the viewport. Okay, and so our observer is observing that. And so now here you see that the intersection ratio at the time that this callback here was called, so this one here, was at 0.10 and then this. And so that's exactly the 10% threshold that we defined over here. All right. We also get this is intersecting property, which in this case is true. And that is because indeed our target, so again, this whole section here is now intersecting the viewport. And we are looking for the viewport, remember, because we set the root to null. All right. So we also get the target itself here and a couple of other stuff, but the intersection ratio is actually the most interesting one, and also the is intersecting here. Okay, so let's scroll down a little bit more, and let's close this actually, and let's scroll up again. And so again, we get a new entry here. And so again, it should be close to 10%, but now it happened as we were moving up, right? And so again, it was at 10%, but now it is no longer intersecting, okay? And it's not intersecting because the threshold is at 10. And so now less than 10% basically of our target here are inside of the root, so inside of the viewport. All right. And so you can start to see why this is more efficient. So it's because we only get this kind of event here in the situation that we're actually interested in. So in this case, that's this threshold of 10%. Okay, and as we keep scrolling here, now it will come back again. And now it is again intersecting. Let's keep scrolling, and all of this here is section 1. And now we got another one. So let's see. And so now it is back to not intersecting, and because now we no longer have 10% visible. Okay, so you can think of this threshold here at the percentage that we want to have visible in our root, so in our viewport in this case. And so right now we are back to having less than 10%, and so it is no longer intersecting here. And again, if we scroll up a little bit more, then we get another event here, because now we are back to having 10% intersection ratio. Okay, so this is the very fundamentals of how the intersection observer API works. And I confess that it is a bit confusing, and it took me quite some time to figure all of this out. And so probably the best idea is for you to stop this video now and explore this a little bit on your own. So you can use different threshold values and maybe use different targets here. You can even use different roots. And so it would be a good idea to experiment a little bit more with this. Now what I'm going to do here is to now specify an array. So to specify different thresholds. And one of them is going to be 0 and the other one 0.2. So that's 20%. So 0% here means that basically our callback will trigger each time that the target element moves completely out of the view. And also as soon as it enters the view. Okay? And so that's because the callback function will be called when the threshold is passed, when moving into the view and when moving out of the view. And this is really important to remember here. On the other hand, if we specified 1 here, like this, then that means that the callback will only be called when 100% of the target is actually visible in the viewport. So in the case of this section 1, that would be impossible because the section itself is already bigger than the viewport. But let's now experiment with 0 here. And so right away, we again get this event here. And you see that the intersection ratio is exactly at 0, but it is already intersecting. And so it's because basically the threshold here was already passed. All right. So I think another one happened there. Let's just reload. Oh, and that was probably from our 20%. Yeah, so you see, this is the 20 threshold, the one that we set here now. And so this one now happened a little bit later than before, because before it was happening at 10%, but now only at 20. So that's a bit later. Let's just clear this and keep scrolling. And so now this section is almost scrolling out of view. And you see, we now get this 20% here. So a bit less than 20%. And as we keep scrolling, then as this line hits here the top of the viewport, we should get another one, which is when this 0 here is again reached. So let's try that. And indeed, here it is. So we are back to intersection ratio at 0, and the element is no longer visible. All right. So this is how the intersection observer API works. And let's now quickly use this in order to implement our sticky navigation. Because at this point, I'm sure that you can already imagine how this can be very useful for implementing this in an easy way. So let's think about this. When do we want our navigation to become sticky? Well, we want that to happen essentially when the header moves completely out of view. So basically all of this part here, which is the header, when we can no longer see it, that's when we want then to display the navigation. Okay, and so this time we are going to observe the header element. So let's start by selecting that. And it is an element with the class of header. All right. Let's actually get rid of this part here. Okay. And now let's create our observer. So this time I'm calling it the header observer, just so we know exactly what is being observed. So new intersection observer, and then I'm going to pass in the arguments later, and then I will use the header observer to observe the header. Okay, so this all kinds of sounds like normal English sentences if we read it like this, right? So here we again need a callback function. So let's just call this sticky nav, actually, and then again the options. Now this time I will just create the options object right here. All right. And so the root will once again be null because we are again interested in the entire viewport, and then the threshold. So I said that we are interested in showing the sticky navigation as soon as this header scrolls completely out of view. So what threshold does that mean? Well, that's just 0, right? So when 0% of the header here is visible, then we want something to happen. Okay, and now let's define this function here. And here we will have exactly the functionality that we want to happen. So to add and to remove the sticky class. So this function gets the entries, and this time I'm not going to specify the observer because in this case we don't need it. Also, there is only one threshold here, so I don't need to loop over the entries. We can simply get the first one, and let's actually use the structuring to get the first element, so entry, to get the first element out of entries. And remember that this is the same as writing entries 0, right? So let's just start by taking a look at this entry just to see if it works. And here, one more time, we already get something. So I'm not sure why that is actually, because this has nothing to do with our threshold. All right, but let's just wait for the next one. And so it should be appearing soon because our target, so this header, is almost moving out of the view. And indeed, here it is. So intersection ratio is 0 and it is no longer intersecting. And so now let's actually create the logic of adding and removing the classes. So basically what we want to do is to first add it here. And so let's start with that. But you see that now it actually already applied this class. And that's because right now our target element is intersecting the root, so the viewport. All right, so we will use that in a second. Let's just see what happens next. So here we will now get our next one, right? And so now it is no longer intersecting. So intersection ratio 0, but no longer intersecting. And so this is actually the condition that we are interested in, right? So only when the header is not intersecting the viewport is when we want to add that sticky class. Because watch what happens when we move back up. So right now, you see we got this new entry here. And so in this case, it is again intersecting. And in this case, where we are scrolling up is when we actually want to remove that sticky class, right? So we are entering the header again. And so that's the point in time where we want the sticky class to be gone. And so now we can use this intersecting property to do exactly that. So we can say that if the entry dot is intersecting is false, basically, then do this, right? So again, when the target is not intersecting the root, then we want the sticky class to be applied. And else, we want to remove it. So let's reload. And now, indeed, the sticky class is no longer there. Okay, and now watch what happens as this line reaches the top there. Then, yeah, here it is. So there is our sticky navigation. So that's great. And indeed, it is because it is now no longer intersecting. And so now the final test is when we move back up, then it is gone. And so as we scroll around this point, it will basically add and remove the class according to the scrolling direction. Now we're actually not really done yet because I want to make this a little bit different or a bit better. So let me show you the demo here. So just to make sure, I'm going to reload it here. Never mind this effect you just saw here, but watch when the navigation comes in here. So you see when that happens, it's basically when the distance between the start of the section and the viewport here is just the same as the navigation. You see that? And so like this, the navigation doesn't overlap this section here right in the beginning. So here the navigation comes exactly before the first section starts. And so let's implement it here as well. And thankfully, that's pretty easy to do. And we can do it by specifying another property here, which is the root margin. Okay, and this root margin here, for example 90, is a box of 90 pixels that will be applied outside of our target element, so of our header here. Okay, and so now it is as if the header did not stop right here, but instead out here. All right, so as if the header went all the way here. Now we actually want the header to basically stop here. And so that's minus 90. Okay, and here we then need to specify also the unit, which has got to be pixels. So unfortunately, percentage does not work, and also rem does not work. So it has to be pixels. And so that's why I'm using 90 pixels here. And 90 is the height of the navigation. And so let's test this here again. So let's see. And so let's wait for it. And did you see that? Indeed, now the navigation appeared exactly 90 pixels before the threshold was actually reached. So you see, now we get the event here even later. And all the data here is still the same. This is simply a visual margin that gets applied. So you can play around with this as well, with the difference between a positive and a negative margin to figure out really how this works. Because this root margin here is very important to specify correctly as we need it in many situations. Now, just as one final detail, let's actually calculate this height here dynamically. And for that, we can use again the getBoundingClient rect function. Because, for example, if you have a responsive site, then probably the size of all your elements will change at certain points. And then it's not a good idea to have this 90 pixels here hard-coded right there in the code. Let's just take a look so we see what we actually need to get. So this is the rectangle. And so here we actually have a height property. So this is where that 90 comes from. So let's read that directly here. Height. All right. And so now here we can use that. Let's create a nice template string here. Nav height. And with that, I believe we're actually done. All right. And of course, this works no matter how large or how small the viewport is. Okay, now it works beautifully and correctly in all situations, and this is a lot more performant and a lot better than the solution that I showed you in the previous lecture. So play around with this, but we will actually also have, I think, 2 more examples with the intersection observer API coming up. And so that's going to be another great opportunity to learn how this API really works, because it's quite important actually to do things on certain positions on the page. So things related to scrolling. Let's implement another really cool and modern feature using the intersection observer API. And this time we're going to reveal elements as we scroll close to them. And this effect can give your pages a very nice touch, and you can in fact easily implement it without any external library. So the effect that I mean is this one here with the sections. So watch what happens here. So you see that we basically reveal each section as we approach it. All right. So I'm not talking about these images here yet. So I'm just talking about the sections. So see how it basically slides in like this. All right. And so that's what we're going to do now with all these 4 sections. Now the animation itself actually comes from CSS. And so once more, we will actually achieve this by simply adding a class to each of these sections as we approach them. And so we will do that using the intersection observer API once again, because that's really the perfect job for this tool. Okay, so let's actually take a look at our CSS here. So I'm going to write or to search for a section hidden. So this is the class here. And so basically all the sections by default have this class. So let me show that to you also. Well, actually they don't. And of course they don't, because then we could not see them right now. Okay, so we have to add them now as we build this. And so this will basically give them an opacity of 0, and it will move them a little bit down. And so then when we remove this here, it will then move them back up to a translate of 0 rem, basically. Okay, so what I'm going to do is to start by adding this section, or this class actually, to all the 4 sections that we want to apply this effect to. So this one here, then the next one, number 3, and number 4. Yeah. And so now all of them will disappear. Okay, they're simply invisible. They're still there, so we are still like displaying them, and so they preserve their height, basically, but they're now invisible. And so our job is now to remove this class as we approach each of these sections. So reveal sections. So let's say a section observer, new intersection observer, and then here the callback, and let's already create it here. Let's call it reveal section, like this. Entries, and this time we will need the observer, and you will see in a minute why that is. So observer, and of course these parameters here, as always, can have any name that we want, right? So just like in the callback functions of the array methods, where we can also give them any name. And here it's the same, but this is kind of the standard, and so that's why I keep doing it like this. So reveal section, and then the object of options. So we want to observe all the 4 sections actually in this case. And it is indeed possible to observe them all using the same observer. So let's select all the sections, and then we will observe these as multiple targets, all using this observer that we just created here. So all sections is document.query selector all. And so that's simply the class section. And now we can loop over this node list with for each. So we use for each whenever we want to do something which does not involve creating a new array. And so here the callback function, I will call it section. And then just like before, we will use our observer to observe section. And actually, since we're already looping over all these sections, it would probably be a better idea to add this class here, so this section hidden, also using JavaScript. So not do it manually here in the HTML, and instead do it in JavaScript. Because some people actually disable JavaScript in their browser, and then for those users, the page wouldn't really be visible, right? They would then have no way of removing this class. And so this is probably not a good idea. So I will copy it now, and then I will just undo everything we did. So yeah, so now it should be back to normal, and it is. And now I will do that programmatically here. So that's a lot better. Don't know why I didn't think of that right away. So class list add, and so this is nothing new at this point. Let's see. And now they are back to being hidden. So let's start by taking care here of these options. And as always, the root is going to be the viewport, so null, and then the threshold. We will set it to something greater than 0. And that's because we don't want to show the section right as it enters the viewport, but a little bit later. So let's say 15%, for example, for now. So this will make it so that the section is only revealed when it is 15% visible. All right. So this is all of the setup. And now let's create basically the logic. So in here. And once again, we have only one threshold. And so let's get that entry from the entries using destructuring. And as always, let's start by logging the entry here. Give us some more space. This 90 is coming from up here, so we don't need that anymore. Okay, and so now we see that some section here is already being intersected at 0%. And so now actually this target element will become important. And well, right now there is no target because this first, so to say, event is always triggered no matter what. So let's scroll a little bit until 15% of the first row is intersected. And of course, that intersection happens even though we cannot see it. So we don't see the row, but still it is now 15% intersecting. And now the target here is actually important. And so here we actually have the class name. So section and section hidden. And so this means that actually a certain section did now intersect the viewport. Maybe we can see the ID. Oh yeah, here it is. So it was the section 1 indeed. So the one with the ID of 1. And this target will now actually be important because now we want to make exactly this section visible, not all of the sections, right? But we are observing all of the sections here with this same observer here, right? And so now we need a way of knowing which is the section that actually intersected the viewport. And so that's what we can use the target for. And so let's do that. So that's at entry dot target. And now we can, as always, manipulate that class list and remove this section or this class that hides it. And you see that it's already working. Well, it actually happens a bit too soon, it appears. But on this one, it was perfect. Let's see the next one. And again, it worked just fine. And the last one as well. Let's try again this one here. And for some reason, it's already there. And I guess the reason for that is this first entry here that always gets printed in the beginning. So yeah, you see that the target here is actually this first section. Now it is not intersecting, and so let's now use that to our advantage. So we only want to trigger this removing here when the section, so when the target is actually intersecting. So if entry dot is intersecting, then do this. And actually, I'm going to use another guard clause here. So I will do the opposite. So I say, if it's not intersecting, then return right away. Okay? But if it is intersecting, then the function will not return, and simply the rest of our code is going to be executed. So let's try that one more time. And now you see it's not yet visible, but it will become visible soon. And there it is. Beautiful, and it still works. All right. So that's a really nice effect, right? We can just do one more small improvement, which is to now unobserve these sections. Because you see, as we keep scrolling, the observer keeps observing the sections. So you see, as we keep scrolling here, more and more of these events keep getting added. But in fact, they are actually no longer necessary because we already did all the work that we wanted. And so we can now unobserve. And so that is again by doing observer.unobserve, so the opposite of observe. And then again, we need to pass in which element should be unobserved. And so in this case, that comes from entry.target. So let's see what happens now. So the first time, of course, we get these logs here because, of course, work is being done. But right after that, each of these sections is being unobserved. So let's go to the end here. And when we clear this now and keep scrolling, you see that we get no more events here. And so that means that none of these sections is being observed anymore. And so that's going to be even a little bit better for our performance. All right, and that's actually it. So another really cool use case of the intersection observer API. One of the most important things when building any website is performance. And images have, by far, the biggest impact on page loading. And so it's very important that images are optimized on any page. And for that, we can use a strategy called lazy loading images. So let me show you now how to implement that strategy in JavaScript. And the effect that I'm talking about is this one. So what happens with the images in this section here. So you see, as we approach it, it basically starts to load. And then once it's finished, it will get displayed. And that placeholder, which is there in the beginning, gets replaced. So you see that? So let me quickly show you in the HTML how we implement that. Oh, and we're actually already here. So it's these features here. And so each of these features has an image. So the main ingredient to this lazy loading strategy is that we have a very low resolution image, which is really small and which is loaded right in the beginning. So that's this image here. And you see that the dimensions are only 200 times 120 in this case. So let's actually take a look at that image here. And so you see it's really small and it's only 16 kilobytes, while the real one, so this one called digital, is almost half a megabyte. So that's a huge, huge difference. And that image we then reference here in this data source attribute. So that's a special attribute that we can use, but any other would work as well. So this is not a standard HTML attribute, but instead it's one of these special data attributes that we can do ourselves. Okay, and so basically the idea is to, as we scroll to one of these low resolution images, we will then replace this low resolution image with the one that is here specified in the data source attribute. And we then also are going to remove this class here, which is kind of this filter which makes this image blurred. Because without this filter, let me show that to you. Without this, it would look really terrible. So, too small to change this now here. Okay, but let's just remove it here for a second, just so you can see what it looks like. And so maybe you can see, or maybe it's too small, but notice that it's like really pixelated and really ugly. Okay, and so I created this filter basically, and so it makes it look like this. So it hides the fact that it is actually way too small for its size. All right, so let's put it back here. And so this is what this class looks like. It's simply a blur filter. And so modern CSS allows us to do this really cool effect. Okay, so let's implement this. And that's actually not too hard, using the intersection observer API one more time. So lazy loading images. And so once again, this one is really great for performance, while the other things we did so far are more visual things. This one really impacts how your site works, and especially for your users who might have a slow internet connection or a low data plan or a slow cell phone. And we always have to think about these users as well. Not everyone has a super high-end computer or the latest phone. All right. Anyway, let's start by selecting our images. So let's call them image targets. And this selector is going to be a little bit different this time, because we don't want to select all the images. So we could simply do a selector of image, and that would then give us all the images. But however, not all of them are going to be lazy loaded. For example, this one here, or we have some down here somewhere. Yeah, so these avatars here, or even this logo. So these are not lazy loaded. And so the ones that will be lazy loaded are the ones that have this attribute here. So this data source attribute, because that's where we specify the real high resolution picture. And so we can actually select for elements which contain this property. So if you're familiar with CSS, maybe you know how to do that. But in case you're not, this is how it works. So we select all the images which have the property of data source. Okay, and that's it. So let's check that, just to be sure, so that it's going to work. And so indeed, here we have these three images. Okay, and nothing else. Then let's create our image observer. And so this is now always the same. Here our callback function, which I'm going to call load image in a second, and then our options. And now let's attach this image observer here basically to all these targets. Okay, so I'm going to loop one more time over our targets, just like we did with the section previously. And this time let's actually use an arrow function, because all we want to do is to use the image observer that we created previously to observe each image. Now let's create that callback function here also pretty fast. So it gets the entries and also the observer. Now, okay, as always, starting with the options here, and again the root set to the entire viewport. And let's start with the threshold at 0. And then we can adjust it as we go. But what matters really here is this callback function. So as always, this is where our functionality is. And so again, we have only one threshold, so only one entry. So I'm getting that here. And now let's check out actually this entry. Okay, so here we already got 3 of them, but all of them are not yet intersecting. Or actually it says that this one is. Well, but it isn't really, because it's down here. So that's a bit weird. Oh, but of course, this still comes from the sections. So this is still coming from up here somewhere. Okay, let's delete it here from the sections. And now let's see if it's working. And now it is indeed an image. Okay, now it appeared a little bit before, and that's because remember that our sections are actually a little bit shifted, right? Because of these hidden class that we added to them, they are shifted 8 rem down. So remember that from here. Let's see. Yeah. So because of this translate here, they are moved 8 rem down. And so then therefore this event will fire a little bit early, but that's not a problem at all. All right. What matters is that the event fired correctly and that it is indeed intersecting. Let's just clear it here to wait for the next ones. And so here you get the next one already. And so that is indeed this next lazy image here. And then the next one here as well. Oh, so this one. Okay. And then as we're moving out of them, then we get even more, because now they're no longer intersecting. And so once again, we need to only do something if they are actually intersecting. So we're going to use the same guard clause as before. So if they're not intersecting, is intersecting, then we want an early return. But otherwise, we now want to replace the source attribute with the data.source, right? So as we reach the image, it's finally time to replace the placeholder image, which is at the source, with the one we actually want, which is data source. So just like before, each of these images here is at target, or actually at entry dot target. So that's the element that's currently being intersected. And then dot source equals entry dot target dot dataset. Remember, that's where these special data properties are stored. And then dot source from there. Okay. So this is already the main functionality right here. So let's try that. But you will not really see it happening because there's still this blurry filter here on top. But if we inspect this now, we should already see that the source is now actually already the original image. So you see that it's the really big one, while the other ones are still the lazy ones. Well, at least this one. The second one is already also the original one because it's already in the viewport too. All right. So that's great. That's working just fine. Now all we need to do is to then remove that class that has this blurred filter. So that's the lazy image class. Now, how do we do that? Well, it's a little bit tricky because this replacing of the source attribute actually basically happens behind the scenes. So JavaScript finds the new image that it should load and display here, and it does that behind the scenes. And once it's finished loading that image, it will emit the load event. And the load event is just like any other event. And so we can just listen for it and then do something. So on that image, so that's entry.target, we can do add event listener and listen for the load event. Okay. And actually, let me show you why it is important that we do this. So let's say that we removed that lazy image class right away. So entry.target.classlist.remove lazy image. Let's scroll up here, reload. And then, well, in this case, the loading happens so fast that we don't even see a problem. Maybe we can change that here in the network tab. So this is a completely new tab, but what we can do here is to simulate or speed. So this is a bit too big here, actually, I guess. So I'm not used to this size. Let me make it a little bit smaller. So let's change it here to fast or to slow 3G. And maybe then we can see what happens. So it's now faking that these images are loading really slow. So did you see them here blurred now? So it's really blurred. You see? But we already removed the filter. And so here you can see how the image is loading basically in the background. And so it's doing that really slow now because we said that we are on a slow network here. And now you see it's finished here, and now the original image is being displayed. So hopefully you could see that. I'm not sure if the resolution of the video is going to be good enough to see it, but I did for sure see it. And here actually now the same is happening. Let me increase the size of the window a bit maybe. So you see it's pretty blurred, but once it's going to be finished, you will then see the final and beautiful version showing up here. All right. So we're going to come back to this network tab later when we start loading data from remote sources on the internet. So this is a very important tab in the browser tools. But for now, it's also nice to see the images loading over time behind the scenes. Well, it's taking a lot of time. So let me just go back to the code here. And so, yeah, now it's finished actually. And so by the time this loading finishes, it will emit this load event. And so it is best to then only remove that blurry filter once that is done. All right. So it's loading again, very slow now. And you see that now it keeps being blurred and it will only disappear once the image is in fact loaded. So I'm not going to wait for that because it seems like it's going to take forever. Oh, actually it's already done here. And so you see now the image is done loading and at the same time the filter appeared or actually disappeared. Let's set it back to online. And so now all of it happens basically at the same time because we are working on our local development machine. And so there, of course, the image basically arrives instantaneously. Now, as a last step, we can just, as we did before, stop observing these images because it's no longer necessary. We already did our task of loading, and so we no longer need this. So entry.target, and that's it. So I hope that with this video, I could convince you that it's really important to implement this kind of functionality into your own sites. So all you really need to do is to generate these placeholder images and blur them a little bit, and then implement this kind of logic, which really shouldn't be too much work, right? Let me just get rid of this console.log here. Let's load it again, because actually we want probably to load the images a little bit before we actually reach them. So ideally, we don't want our users to notice that we are lazy loading these images, right? So all of this should basically happen in the background without our user noticing that. And so we should probably make these images load a little bit earlier. So to do that, we can again specify a negative root margin here. So root margin of, let's say, minus 200 pixels. All right. And so this is just the same as we did previously here with the navigation. So to make the navigation load a little bit before the threshold was actually reached. And here we are doing the same. So exactly 200 pixels before any of the images is loaded, it should already start loading. And by doing that, we don't see any delay in loading when we browse the page. Well, actually, that didn't quite work. Maybe it should be plus 200. So as you see, this is all a matter of trying out and figuring out as we go here. And so now, indeed, as we approach the images, they're already fully loaded. So now that happens 200 pixels before we reach them. All right. And with that, our functionality here is complete. And we are now indeed almost finished with this project. All that's left to implement is really this slider. So this component here. And so that is what we're going to do in the next video. Let's now build the really cool slider component. And this is going to be a lot of work. So we're doing that in two parts. And so here goes part 1. So this is what the final version of the slider looks like. So we can click these buttons here to move between the slides. And you see that also the dot down here then changes. And as we reach the last slide, as indicated by this last dot, if we then go to the next one, it will basically go back to the first one like this. And of course, we can also click on the dots like this. All right. So let's now understand how this is actually implemented in terms of HTML and CSS, because as always, that's a very important aspect to make this all work. Okay. So this is the slider component, and then each slider has a couple of slides. So 3 slides, and they are in fact all side by side. So we have slide 1. Make this smaller here because the content doesn't really matter. So we have these 3 slides. And so you see here by this blue area that they are all side by side. So here in the slider, we can turn off this overflow property, which is set to hidden. And then you can actually see the next slide already waiting there, basically. So what happens when we click this button is that all the slides move a little bit to the left side. So watch. And so you see that now the first slide is here, the second is in the middle, and the third is right here. And that happens by using this transform CSS property, which we then set to translate X. And then here we define these values to basically move each of the slides as we click these buttons. So watch what happens here in these values as I click. And so now the last slide here is basically at 0%. The one before is at minus 100, and the one before is at minus 200. So minus is basically to the left, and the width of each slide is 100. And so basically, this is all we need to do in order to make the slide work. So basically adapt these percentages here as we go. So you see that now the first slide is at 0%, then the other one at 100, and the third one, which is all the way to the right side, is now at 200%. So this is basically the starting position of the slider. And let's compare that to what we have currently in our slider. So we have all of the slides basically on top of each other right now. And so the first thing that we should do here is to basically establish this initial condition where they are all side by side. So like this. And so what we're going to do on each of them is to set this transform property to these percentages. But of course, all automatically. So let's start here with our slider. And as always, I'm going to start with some selections. So starting with the slider, or actually with the slides themselves, so that we can then manipulate them. So document.query selector all. And so that's a slide. So with the class of slide. And we can also, of course, see that here in our own HTML. So you see, here we have the slide. Now the content that is inside of each of these slides is completely irrelevant for our purposes. All right, so all we are concerned with is the slider element and then this slide. So this one and all the others. So I can collapse these just to see. And so, yeah, we are only going to be concerned with the slides. And then you can maybe use this for your own projects in the future and put whatever you want inside these slides. For example, you could just have images or really anything that you want. And in fact, that's what I have down here. So here I only have some images. And maybe we should actually work with that. So let's actually try that. So I will comment out this part. So not really sure how that works anymore. Now, okay. And so now let's make this actually visible. Just to see. All right. So these are our slides now, but once again, they are all on top of each other. And we can see that here when we inspect them. So indeed, all of these slides are in the same position. And so let's create that starting condition that I mentioned a minute ago. So putting all the slides side by side. So let's take the slides and we're going to loop through them and set the style on each of them. So let's create a simple arrow function here. And the parameters I will just call s for slide. And then we also need the second one, which is the index. And you will see in a minute why that is. And so here we want to set the style on each of the sides. And remember, it is the transform property that we want to set. So transform. And then we want to set it to translate x. And then here is where we have to specify the value. Okay. And that value is going to be in percentages. And let me just write down here what we want. So the first slide should be at 0%. The second should be at 100%. Then 200%, and then 300%. Okay, and so that's because translate x will basically move them to position 100%. So the width of each of these images is 100%, and so then the second image will start right here at the end of the first one. Then the third one will start right after the first one, which is at position 200%, and then 300. So how can we calculate these values here? Well, we can simply multiply 100%. So here we need now a JavaScript value. So we can multiply 100% by the current index. So in the beginning, that's going to be 0. So 0 times 100 is 0. And then, as you see, it will go all the way until 300, because in this case, we have 4 images or 4 slides. But if we were working with the other slides, then that would only go to 200% because we only have 3 slides. So that should already be enough. And now we have this problem that our sections here keep disappearing. And that's because the code we wrote earlier. So reveal sections. And so for now, let's remove this observer. All right. Well, the observer can actually stay. What we need to remove is these hidden classes. All right, so now that works. And so let's check out the images now. And we can't really see them. All right, but indeed, they have now 0%, 100, 200, 300, and so on and so forth. Let's maybe temporarily scale down the entire slider. So let's come here to, or let's do that actually here in JavaScript. So just to make this a little bit easier for us to see. So const slider is document.query selector slider. And then what I want to do is slider.style.transform and set it to scale, let's say 0.5. Yeah, so that looks a bit better. Now we just need to change that overflow that I just showed you before. So that overflow here, we need to set to visible. So also on the slider. So otherwise we cannot see the other slides, right? So let's do that as well. So overflow, and we need to set it to hidden, or actually to visible. Okay, let's make this even smaller actually. Even smaller, just so we can see all the images. So you see, now all the 4 of them are here, and our buttons are now really small, so they are still here, but I think we will be able to work with this. Maybe we can just move the whole thing a little bit to the left. So let's say translate X here as well. And keep in mind that this has nothing to do with the functionality. Okay, this is just so we can see what we are doing here. So this works. Or we can move it even further. And so now we can make it a bit bigger again. All right. So that's beautiful. That works for now. And then by the end, we will simply remove all of this. Okay. But now let's actually get to work and make the slider work. And so I will start by selecting these 2 buttons. So that's the button left, query selector. Let's see here. So that's slider button left and button right. And then simply duplicate it. Okay. So button right dot add event listener. And let's start by only working now to make the slide go right. So clicking just on this button here. And I think we're not even going to need the event for now. Okay, so this is basically to go to the next slide. So remember that going to the next slide is basically simply changing the value here in the transform property. So this translate X, all we will do is to change the percentages so that basically the slide that we want to move to is the one that has 0%. So remember that this is what we did here. So right now the active one is the one that has 0%, and the previous one has -100 and the other 100. So again, that is the whole mechanism that we're using here to move the slides. And so this is what we will do now. So in the beginning, we are at slide 0, but then when we want to go to the next slide, we need to increase that. So let's outside here create a new variable for the current slide. So let current slide, and it is a let because we will of course then update it. So we start at 0, and then when we go to the next slide, we simply increase that by 1. All right, and so right now it is 1. And then what we need to do is to basically do the same as this, but with a small change. All right, so let's say that the current slide is 1. Then we do not want this here, right? We don't want this, but instead we want the first slide to be -100, this one 0, this one 100, and the other one 200. So how do we do that? Well, we take the current index, and then we subtract the current slide. So again, we will take this, so each slide that we're looping over, and then minus the current slide, so like this, and then this will give us exactly what we want. So again, let's say that the current slide is 1. Let's write that here, actually. And so then, as we loop over these slides, in the first iteration, this will be 0, and then 0 minus 1 will be minus 1. And then times 100 is, of course, minus 100. Then the next slide, the index is 1, and then 1 minus 1 is 0, and so that will then become 0%. And so remember that the active slide is exactly the one that we want to be 0%. And so this should now actually work. Let's see. And yeah, it is already moving. So the first part is already doing its job, but now we are kind of at the last slide here. So let's see what happens next. So it actually keeps going. So the number of slides keeps increasing, and so of course these values here also keep increasing, because, well, JavaScript doesn't know that we are working a slider, and so of course it doesn't stop. We need to tell it to stop. So how can we do that? Well, the best way is to actually define the number of slides and then make it stop once we reach the last one. So let's say that the max slide, so the maximum slide where we can go, is slides.length. So basically the length of this node list here. And on node lists, we can also read the length property just like on an array. So here, when we define the value of the current slide, we now need to update this a little bit. And so if we are at the max slide, so if the current slide is equal to the max slide, then we want the current slide to become 0 again. And so that's how we return to the beginning of the slides. And otherwise, we will simply increase the slides by 1. Okay, so let's test that here. So everything keeps working. Now we are at slide number 3, and so we are at the end. But actually this max slide is 4. So the length is 4, but the index is 3. And so as always, that's because the length is not 0-based. And so probably it will keep going one more time, and then it will return to the beginning. Yeah, beautiful. All we need to change here is to add -1 to this to basically also make this 0-based. And so now, let's see. Well, our slider is basically already working. So at least in this direction. So this button, of course, not. But here, we can see that it's doing its job already. So that's really nice. Let's now just quickly refactor this code a little bit. So we have here basically the exact same code, or at least almost the same code as here. But we can refactor this into its own function. So let's grab this here. And I will create a function now called goToSlide. So that's a function where we pass in the slide. So basically the number of the slide where we want to go to. And then here we change the current slide to the slide that we are indicating. And here I can then call this goToSlide with the current slide. So far we didn't change anything. Just delete this comment here. And now to be able to remove this part here, all we need to do is to basically call this function here right in the beginning of our code with the slide set to 0. So this slide argument set to 0. And so what this will do is then basically once our application starts, it immediately goes to slide 0. And so that will then execute basically this code. So slide will be 0, and so I minus 0 is then of course just I, and so that's then exactly what we have here. So go to slide 0, And so now I can delete this, and that's great. Then to make this just a bit more beautiful, let's actually also take this one here and create a new function for that. So const next slide, and then put it here. And this one doesn't need any parameters, because the goal of this is really just to export the functionality into its own named function. All right. And so indeed it keeps working just as before. Next up, let's then work on this button here. And so all I need to do is to add an event listener to button left. Also click, and then I'm going to create a function called previous slide, or just prev slide. So let me create that here very quick as well. So const prev slide. And so in this case, the current slide will be decreased. And then here, I can simply reuse the same function that I already wrote before, and also with the current slide. So the functionality of moving to a slide is of course exactly the same, no matter if we go forward or upward. So all this will do is to update the transform property on all of the slides. And that works in always the same way, no matter if we're going forwards or backwards. So the main difference between the next and the previous slide is really the way in which we determined the current slide. So when we go to the next slide, we basically increase the current slide, and when we go backwards, so to the previous slide, we simply decrease it. So let's try that now. And first we need to go forward because our function there is not really complete. But in this situation, it already works just fine. But then as we keep going, we have the same problem as before, because we simply keep decreasing the current slide. And so we now need to fix that. All right. So in which situation does simply decreasing the current slide not work? So it works right now. So now it works, right? But now it does not work. And so that is in the situation where the current slide is already 0. So let's write if the current slide is 0. So in this case, the current slide should be equal to the max slide. And again, that's -1 because that max slide is not 0 based. And then else. And so now that should actually work. And indeed, beautiful. And so now our slider is actually working already. We are just missing a couple of features. So namely, these dots here, which is a little bit complicated to implement. And also in this version, we can use the arrow left and arrow right functions to move through the slider. All right, so now I'm just hitting the left button and the right button. Okay, but I'm gonna leave that for the next video. For now, let's just get rid of these things that we did in the beginning so that we can see the actual slider in all its beauty. So now it does indeed look like a real slider, doesn't it? So I'm really happy with this result, and I hope that you're as well. And of course, I wouldn't expect you to be able to write this code on your own just yet. So when we implement something like this, there is a lot of stuff to think about, and especially in this case, the most tricky part is, in my opinion, this here. And this probably comes from experience, and so at a certain point, if you practice enough, you will also be able to come up with a logic like this. So I just invite you to study this code here a little bit before we move on. And once you're done doing that, then let's move on and implement these dots at the bottom of the slider that I just showed you. Let's now continue building our slider component. And let's actually start by attaching an event handler to a keyboard event so that we can also slide through the slider using the left and right arrow keys. So let's do that after these ones here. And remember that we actually handle keyboard events right at the document. .add event listener. And then we're going to use the key down event. And so that's going to be fired as soon as the key is pressed down. And here we need the event. And let's start by taking a look here at the event so that we can figure out which keys we actually want to use. So I'm going to hit the right arrow key. And so you see that we get the key here as arrow right. And then the other way around, it is of course arrow left. And so I'm going to use that key, arrow left and arrow right. So that's very simple. If e.key equals arrow left, then what we want to do is to call the previous slide function, right? And so this is also a reason why I created a separate function for this. Okay, so otherwise I could also have left the entire code just here instead of exporting it into its own function. I still prefer it like this, but it wouldn't have been necessary. But now, as we need to reuse the same code here as well, then I really would have to create it its own function. Now you might have noticed that here we also could have used like short circuiting. So we could do e.key equal arrow right and next slide. So this would work the same way because of short circuiting, right? At least I hope so. And yeah, it does. So I just hit the right key and here the left key. And so it works just as fine. So you can now choose which version you like the most. So I'm going to leave both here and let you decide which one you want to use. All right, but now about the dots that I was talking about. Let's go here to our HTML, because here we actually already have a div, so an element for that. So we have the buttons, of course, these two, and then we also have this empty container in which we're going to create the dots. So let's start by selecting that element, and I'm going to call it the dot container. So that's just dots, I think. Yeah, that's correct. And so let's start by creating all these dots in there. So I'm going to create a new function here. So basically, I'm nicely organizing the entire code of the slider here into different functions. And so that's a good pattern to get used to. All right. So just so you see what these dots will actually look like. So each dot is going to be one element with the class of dots dot. And then it will have this data attribute of slide with the number of the slide that clicking the button will go to. All right. So one more time, the data attribute here holds some data that we need in order to make the functionality work. Let's actually grab this code here. So I'm copying all of it now. And so what we want to do here now is to create one element like this for each of the slides. So the easiest way of doing that is to simply loop over the slides, because then we can do something for each of them. And in this case, it's not even going to be about the slides. It's just so that we can do it 4 times because we have 4 slides. So we have the slide again and then the index. But in this case, we're really only going to be interested in the index. So missing the function keyword here. And actually, since we're not interested in the slides, we can again use this convention of the throwaway variable. so a variable that we don't even need. And so let's now say .container .insert adjacent HTML. So as I mentioned, this is my favorite way of creating HTML elements. And so let's say before end. So basically adding it as the last child always. And then here we need the HTML code itself. And so let me just paste that button, so that code that I copied from the demo site. And now here, all we need to do is to add the index. And so then the first button will get index 0, then 2, 3, and 4. So that in the next step, we can then read this value from here and move exactly to that slide once one of the dots is clicked. So let's check that out. Oh, and of course, we need to also call this function. So in the beginning, we need to call go to slides and also create dots. So create dots. And I will organize this a bit nicer by the end. For now, let's just leave it like this. Oh, and you see, we have the 4 dots now here. All right, let's check them out here just to see the data slide attribute. And indeed, 0, 1, 2, and 3. And now let's actually make them work. So adding another event handler here. And I like to keep the event handlers or event listeners here at the bottom. And so, of course, we are going to use again event delegation. So we're not going to attach one event handler to each dot, but instead to the common parent. And so that is, of course, the dot container into which we just added the dots. So add event listener waiting for a click. And now to actually match the element that we're interested in, we can simply now check for the class. So that's event.target.classList.contains, and then the class of the dots is dots __ dot. All right, and if so, let's just log that to the console pretty quick. So here we get dot. If we click outside somewhere, nothing happens. And then again dot and dot. All right, so let's get the slide. So const slide is equal e.target.dataset.slide. And so that's because it's called data slide. And so as always, all the custom data attributes are in the dataset and then dot this value. So dot slide. So dot slide. And to make it even better, we can now use destructuring because this value is exactly the same as this. And so we're reading from this object. And so we can simply do this. So another nice use case of destructuring right there. And so now what we want to do is to basically go to the slide that we just selected. And so one more time, it's now very handy to have this go to slide function here inside its own separate function. So go to slide, and then with the slide number that we just read from the dataset. So let's test that. And it works. So slide 2, let's see slide 1. Let's go straight to the last one. And it jumped over all the others. And now we are at the last one. And of course, we can combine this now with the buttons and with the keyboard arrows. And so, yeah, great. This works as well. Now all we need to do is to also show which is the current slide. So activate this dot, basically. So give it this different background color. So that's also pretty common in a slider like this. And let me actually show it to you. So all we do, as always, is to give it a special class. So the dots.active class. So let's go back and let's do that not here, but in another function, because we need this functionality in many places. So whenever we change the slide, we will also need to change the indicator here. So no matter if we click on one of the dots or if we just use these buttons here, whenever we change the slide, we want to change which slide is currently the active one. And so we're going to create a completely different function for that. And let's do it here after create dots. So activate dot. And here we need to, again, then pass in the current slide, basically. So how will we do that? Well, it's going to be a bit similar to what we have here with these buttons. So here we also had like an active class to show which one is the active button here. And to do that, remember, before we activated one of them, we first deactivated all of them. And so here we are going to do the same. So we will select all of the dots each time that we want to activate one, and we will then remove that active class and then add it only on the one that we're interested in. So let's select all the dots. So that's document.query selector, and actually query selector all. And so the dots are the one that have this class. And then for each of them, so let's call it dot. We want to say dot class list dot remove this class dash dash active. So that's the first step of removing all the active classes, and then we will add it only on the one that we are interested in. So how do we select the one that we actually want? Well, we can do that also based on the data attribute. So that's going to be a bit complicated. So let me show you how. So document.query selector. And so here the query is going to be a little bit more complicated. So it's still dots underscore underscore dot, but now we want to select based on the data slide attribute. So basically based on this attribute. And we can create a selector for that. So remember how previously we used these brackets to select for images with a certain attribute. And so here we can do that as well, and even check if they have a certain value. So data slide equals, and so they should have exactly the value of slide. And so then the selected dot we can add to the class list or class, so the active class, just like this. So let's say we pass in slide number 2. So we want to activate the dot corresponding to slide number 2. And so here in this query selector, we can basically select the element with this class and with this data slide attribute set to 2. So write like this. Okay, and here that's active. And so now that should actually be working already. All we need to do is now call this function here in all the necessary places. So when we go to the next slide, we go to the slide, of course, and then we also want to activate the dot. And also on the current slide. And then the same when we go to the previous slide. Activate dot with the current slide. And finally, when we click on one of the dots. So activate dot, and here it's just called slide. Okay, let's try that. And did it work or not? Well, it's hard to see actually here because of these images. But yeah, apparently it is working. Although it looks kind of the same as all the other dots. So let's change that here, the style. But yeah, it's very hard here. So let me change the class here. So let's actually change it to white. So reactivate this one here. Oh, and yeah, you can see that it actually works. So now that's a bit better visible. So that works just fine in all directions. So even with the arrow, of course. And when we click a dot, then the same works as well. There's just one problem, which is when we reload this, then none of the slides is active. So let's go back here and also in the beginning call this activate dot function with slide 0. So activate dot 0. And so now you see the first dot is now active. Great. So that's actually it. Our slider is working now. Let's just refactor our code just a little bit and make it a bit better. So for example, we have all of these function calls here. So let's put them all in the same function, which I'm going to call init. So an init function, an initialization function. So here we have our event handlers. And then here, our functions. So I'm calling the function that doesn't even exist yet. So that's better. And now I will simply put all of these here, just so that we know a bit better what exactly we are going to do in the beginning, basically, to initialize our slider. And there should be one more. Yeah, that's to create the dots. And that should probably happen before we activate any dot. Otherwise, that's not going to work, probably. So here we have then our functions. Let's just write that here as well. And this one we don't need anymore, in fact. And now just to finish, let's actually put all of this code into a function as well. And so this way, we do not pollute the global namespace. So that's something we like to say. And we're going to talk a little bit more about this also later in the course still. But for now, just know that it is a good practice to keep this kind of functionality here, maybe in its own function. So let me actually delete this one and just put one curly brace at the very end here. And then all we need to do is to call that function. And that's it. So now we have our slider working, and we could now actually even pass in some values here. And to make this even more complete, we could actually pass in like some options here. So we could make this slider function accept a couple of options. So an object, for example, which contains these options, and then work with that. But that's a bit too much for this example. But just know that this is a pretty common thing to do. So great, this slider works. Let's just actually go back to deleting these slides. We don't need them anymore, and put back our original content. And so you will see then that it works just the same. And indeed, it does. So I'm just going to change the color of the dot back here. And then that's it. So everything works the same, no matter how many slides we have. So of course, now we have only 3 dots, but everything just works the same. So the slider is really being built dynamically based on the number of slide elements that we create in our markup. Okay. So we're almost done with this project now. There's just 2 more small lectures in which we're gonna learn a little bit more. And so after reviewing this code for this really cool component, let's then just quickly check out these final 2 lectures. Now to close off this section, let's take a quick look at a couple of different events that occur in the DOM during a web page's life cycle. And when we say life cycle, we mean right from the moment that the page is first accessed until the user leaves it. And let's do that right here at the end of this file. Now, the first event that we need to talk about is called DOM content loaded. And this event is fired by the document as soon as the HTML is completely parsed, which means that the HTML has been downloaded and been converted to the DOM tree. Also, all scripts must be downloaded and executed before the DOM content loaded event can happen. And of course, we can listen to that event, and since it happens on the document, we call the addEventListener method on the document, and then the name of the event is, as I mentioned, DOM content loaded. All right. Now, this event does actually not wait for images and other external resources to load. Okay, so just HTML and JavaScript need to be loaded. So let's now take a look at this event, or basically just log something to the console. So HTML parsed and DOM tree built. And we can also take a look at the event. Okay, so let's see. And so indeed, we get the event here right basically at the beginning. And in this case, it's a bit hard to see. And so let's again go to our network tab. And I'm decreasing it here. And I will set it to fast 3G now. And down here, you can actually see the time that it takes for the event to be fired. So in this case, it was just 85 milliseconds, and so therefore it was really fast. So let's try that again with a fast 3G connection. And so now it actually took 2 seconds for the JavaScript and the HTML to load. But you see that still after that, some other code here or some other stuff kept loading. So that's probably all these images that we have here. And of course, as we keep scrolling, then these other images also start loading. So that's what's happening here. All right. So with this here, we can now execute code that should only be executed after the DOM is available. And in fact, we want all our code only to be executed after the DOM is ready, right? So does that mean that we should wrap our entire code into an event listener like this? So with a function like this? Well, actually no, we don't need to do that. And that's because we have the script tag, which is the one that imports or JavaScript into the HTML right at the end of the body. So you see, it is down here. So basically, it's the last thing that is going to be read in the HTML. And so basically, the browser will only find our script when the rest of the HTML is already parsed anyway. So when we have the script tag here at the end of the HTML, then we do not need to listen for the DOM content loaded event. Okay. Now, there are also other ways of loading the JavaScript file with the script tag, but we're going to talk about that in a next lecture. All right. Now, if you're coming to vanilla JavaScript from jQuery, then you're probably used to wrap all your code into a document ready function, which in JavaScript, or actually in jQuery, looks something like this. And so this is equivalent to the DOM content loaded in vanilla JavaScript. Okay, but again, no such thing is necessary in regular JavaScript. Okay, anyway, next up, there is also the load event. And the load event is fired by the window as soon as not only the HTML is parsed, but also all the images and external resources like CSS files are also loaded. So basically, when the complete page has finished loading is when this event gets fired. So as always, we can also then listen to that. So load function, and then here we can log page fully loaded along with the event. So let's take a look here in our console. So we already got this event, and then at the end, when everything was finished, we also got this load event. So you see, it's just a regular event object like we already know. And again, this load time actually appears down here in the network tab. All right, we can also see the amount of kilobytes that was downloaded. And so this network tab is really nice, and it gives us a lot of information about loading our pages. And of course, you can try to explore this network tab a little bit more on your own. Now, finally, the last event that I want to show you is the before unload event, which also gets fired on window. So window.add event listener. And so that's before unload. And this event here is created immediately before a user is about to leave a page. So for example, after clicking this close button here in the browser tab. So we can basically use this event to ask users if they are 100% sure that they want to leave the page. Now, in some browsers, to make this work, we need to call prevent default here. In Chrome, it's not necessary, but some browsers require it. And then we can also take a look at the event itself. Here, let's remove that. And actually, in order to display a leaving confirmation, we need to set the return value on the event to an empty string. So return value and an empty string. And this probably looks a bit weird, but this is for historical reasons. All right, so let me show you what happens as we try to close the tab now. And so now we get this pop-up here indeed, which asks us if we want to leave the site. Now, a long time ago, developers were actually able to customize the message that was displayed here. But then, of course, many people started to abuse this. And so now we can only see this generic message. So no matter what we write here, we will always get this same pop-up. Okay. So let's remove this. And this can, of course, sometimes be useful, but sometimes it's also a bit too much. So let's actually remove all of this here. Okay. Now we cannot even reload the page here. I will actually have to open up a new tab with this and close this one. All right. So really, please don't abuse this kind of feature, because a message like this is, of course, pretty intrusive, and it should only be displayed when necessary. So don't be one of these developers who abuses of too much power. So the only time you should prompt the user if they really want to leave the page is, for example, when the user is leaving in the middle of filling out a form, or like writing a blog post or something like that. So a situation in which data could actually be lost by accident. And that's actually all I had to show you. So that's the 3 events that can be quite helpful in some situations, and especially this one, I would say. All right. And now in the next video, to finish this section, we will take a closer look at this event and at different ways of loading scripts in HTML. To finish this section, let's take a quick look at different ways of loading a JavaScript script in HTML. So up to this point, we have always used the regular way of including JavaScript files into our HTML, like we can see here. However, we can also add the async attribute to the script tag like this, or the defer attribute. And these attributes are going to influence the way in which the JavaScript file is fetched, which basically means downloaded, and then executed. Now in the HTML, we can write the script tag in the document head, or usually at the end of the body. So these are the 2 situations that we're going to be comparing in this slide. So when we include a script without any attribute in the head, what will the page loading process look like over time? Well, as the user loads the page and receives the HTML code will start to be parsed by the browser. And parsing the HTML is basically building the DOM tree from the HTML elements. Then, at a certain point, it will find our script tag, start to fetch the script, and then execute it. Now, during all this time, the HTML parsing will actually stop. So it will be waiting for the script to get fetched and executed. Only after that, the rest of the HTML can be parsed, and at the end of that parsing, the DOM content loaded event will finally get fired, as we learned in the last video. Now, this is not ideal at all, right? We don't want the browser to be just sitting there doing nothing, because this can have a huge impact on the page's performance. Plus, in this case, the script will actually be executed before the DOM is ready. And so again, that's not ideal. So never do this. Never include the script in the head like this. That's why we usually always put the script tag at the end of the body, so that all the HTML is already parsed when it finally reaches the script tag. So in this situation, this is how the page loading process looks like. The HTML is parsed, then the script tag is found at the end of the document, then the script is fetched, and then finally the script gets executed. And this is much better. So if you didn't know why we always put the script at the end of the body, well, now you know. However, this is still not perfect, because the script could have been downloaded before, while the HTML was still being parsed. So what about the async attribute? Well, this is what the loading process looks like when we use async script loading in the head of the document. So as you can see, the difference is that the script is loaded at the same time as the HTML is parsed, so in an asynchronous way. So that's already an advantage. However, the HTML parsing still stops for the script execution. So the script is actually downloaded asynchronously, but then it's executed right away in a synchronous way. And so the HTML code has to wait for being parsed. But anyway, as we can see from the length of the diagrams, this still makes page loading time shorter. But now, what about the defer attribute? Well, when deferring, what happens is that the script is still loaded asynchronously, but the execution of the script is deferred until the end of the HTML parsing. So in practice, loading time is similar to the async attribute, but with the key difference that with defer, the HTML parsing is never interrupted, because the script is only executed at the end. And many times, this is exactly what we want. Now, you might be wondering why I didn't show async and defer in the body yet, and the reason for that is that they simply don't make sense there. Because in the body, fetching and executing the script always happens after parsing the HTML anyway. And so async and defer have no practical effect there. Alright? And so the async and defer attributes have no practical effect here at all. They would make no difference. Alright? Now there are of course use cases for all these strategies. So let's now compare them, except of course the regular loading in the head, which is completely ruled out. So here is what we already know about the three strategies and also the three loading diagrams that we analyzed in the last slide. But let's now compare the async and defer attributes a little bit better. So one important thing about loading an async script is that the DOM content loaded event will not wait for the script to be downloaded and executed. So usually DOM content loaded waits for all scripts to execute, but scripts loaded with async are an exception. So with async, DOM content loaded is fired off as soon as the HTML finishes parsing, And this might actually happen when a big script takes a long time to load, like in this example. So notice how the DOM content loaded event appears right after HTML parsing in both these diagrams. Now, using defer, on the other hand, forces the DOM content loaded event to only get fired after the whole script has been downloaded and executed. And so this is the more traditional way that this event works. Another very important aspect is that async scripts are not guaranteed to be executed in the exact order that they are declared in the code. So the script that arrives first gets executed first. On the other hand, by using defer, that is not the case. So using the defer attribute guarantees that the scripts are actually executed in the order that they are declared or written in the code. And that is usually what we want to happen. So in conclusion, and also keeping in mind what we learned in the last slide, using defer in the HTML head is overall the best solution. So you should use it for your own scripts and for scripts where the order of execution is important. For example, if your script relies on some third-party library that you need to include, you will include that library before your own script, so that your script can then use the library's code. And in this case, you have to use defer and not async, because defer will guarantee the correct order of execution. Now, for third-party scripts where the order does not matter, for example, an analytics software like Google Analytics or an ad script or something like that, then in this case, you should totally use async. So for any code that your own code will not need to interact with, async is just fine. So it's a good use case for this kind of scripts. And I'm saying this because, of course, you can use different loading strategies for different scripts in your web application or website. Okay? Now, what's important to note is that only modern browsers support async and defer, and they will basically get ignored in old browsers. So if you need to support old browsers, then you need to put your script tag at the end of the body and not in the head. That's because this is actually not a JavaScript feature, but an HTML5 feature. And so you can't really work around this limitation like you can do with modern JavaScript features by transpiling or polyfilling. Okay, and this should give you a pretty good idea about different ways of loading JavaScript scripts. So let's now quickly move over to the code and implement this. And here we still have the script at the end of our body. And of course, without any async or defer attributes. Now, before we move this to the head, let's quickly check out here our network tab one more time. And let's use the fast 3G preset now, just so we can see these files here being loaded, and also to see this DOM content loaded event being fired. And so here we can actually see the different assets of the page being loaded over time. And let's search for the script. And so, yeah, here you see that the script actually only loaded, so only started to load after these first images here, and also the HTML itself, which is this one here. So only after they finished loading is when the JavaScript file started loading. That's why here we have this stalled time. And so this is a bit similar to the diagram that I showed you in the slide. Okay, now this time is probably different for you, but just take note of it so we can compare it to the next scenario. So let's now copy this, and I will comment it out using command /. And so now I'm moving it here to the head. Okay, and then I'm going to put the defer attribute, because as we just learned, this is the preferred way of loading our own scripts, and also when the order matters. So from now on, we will always load our scripts like this. So in the head with the defer attribute. So let's give it a save, and this will then trigger a reload here. And you see that now the DOM content loaded event here fired half a second earlier. And so that's because the JavaScript file could start it to load immediately. And so indeed, now here, as we hover this file, we don't have that stalled period. So that period in the beginning where the file isn't even being loaded, right? So this looks different. And in fact, it looks exactly as I showed you in the slide one more time. So the load time is of course different because the assets that we need to download are exactly the same. But what matters is that the page is basically ready earlier in this scenario. All right, so let's put it back. And yeah, with this, we actually finished one more section in one more really beautiful project, in my opinion at least. So one more time, you can add this to your portfolio or show off to your friends, or maybe even potential employees or employers. Just make sure about this notice that I have here at the bottom of this page and in all the other big projects, which is please don't use this project on your own to create your own course. Also don't claim it as your own product as if like you came up with this design on your own. So this is just for learning purposes or for your portfolio. All right, but I think that's pretty obvious anyway. I just wanted to make sure to mention it here because many people ask me questions about what they can do with the projects and what they can't. But anyway, congratulations for finishing one more section and actually by reaching the end of the intermediate part of this course. That's a huge milestone and you should really be celebrating. So great job of going through all these videos together with me, learning all of these important and valuable skills. So take a well-deserved break now, and after you're energized, let's move on together to one of the most important sections of this course, which is going to be about object-oriented programming in JavaScript.